In this video, I'll show you how to solve the ALEKS problem called predicting deviations from ideal bond angles. In order to solve the problem, the first thing that you're going to need to do is draw or look up the Lewis structure for the molecule in the question. I have NO3-. There is literally no way that you can do this problem without knowing the Lewis structure for NO3-. You could draw it yourself, or if you're lazy like me, you can just look that Lewis structure up on the internet. So that is what I am going to do. NO3-. Now you do want to make sure when you're looking this up, be careful. There are a lot of molecules that have similar molecular formulas, so you want to make sure that you're actually finding NO3- and not some other type of molecule like NO3 without the minus charge or something like that. So this one looks pretty reliable because I can definitely see that it's NO3-. It's got some weird notation using dots instead of lines. I'm not sure if I want to rely on that. This one looks good. This underneath it says that it's the structure for NO3-. I can see that -1 charge in there. I'm gonna trust this structure right here. So what I'm gonna do is copy that over here. And again, there's no way to do this problem without having a Lewis structure. So that's definitely going to be your first step. Once you get the Lewis structure drawn, the rest of it should be pretty straightforward. First of all, it's asking you what the central atom is. Obviously, the central atom in this case is nitrogen. It's just going to be the atom that is literally in the center of the molecule. How many lone pairs are around the central atom? In this molecule, there are 0 lone pairs on that central atom. And I know that that looks like an O for oxygen, so I'm just going to write the word 0, although here you would definitely be typing the number 0. What is the ideal angle between the nitrogen-oxygen bonds? So to come up with the ideal angle, you're going to need to consult a table. You definitely have one in your textbook. You can also find them on the internet. You're looking for a table that's going to give you the relationship between the number of bonds on a central atom, the number of lone pairs on a central atom, and then also the bond angle. Now this table is also going to be giving you the shape of the molecule. So you're going to be getting 4 pieces of information in this table. That'll also be shape over here. But for this problem, we're only concerning ourselves with bonds, lone pairs, and bond angle. So for our central atom, the number of bonds we have around the central atom are 1, 2, 3, 3 bonds. And we've already said that there are no lone pairs. And if you consult a table of information with this information, you will see that this is a 120-degree bond angle. So 120. And now it's saying, compared to the ideal angle, what would you expect the actual angle to be for this particular problem? So the actual angle is going to deviate based on the presence of lone pairs that might be on the central atom. And since we don't have any lone pairs on our central atom, we're going to say that there is no deviation. I'm not sure exactly, I don't remember exactly what this drop-down menu says, like what your options are. So it probably says something like bigger or smaller or exactly the same or no change from 120 or something along those lines. We want to look for whatever word or phrase ALEKS is using to say that we're not seeing a change to our bond angle. If there was a lone pair on this central atom, then we would know that that lone pair would be causing this bond angle to become smaller. So we would look for a word here. Like if we have a lone pair, then we know that that makes the bond angle get smaller.